Hi everyone, welcome to this channel. Myself AVABHRATA, the SDM College, Panna. In the previous session, we discussed about the group 15 elements under P block elements. The P block elements involved under the second year syllabus, 15 group elements, 16 group elements, 17 group elements, and 18 group elements. In the previous session, we discussed about the 15 group elements. These elements are nitrogen, phosphorus, arsenic, antimony, and bismuth. So, these are the elements present in the group 15 and these known as group 15 elements. Next, the compounds of 15 group elements. What are the properties of 15 group elements? And what are the common or general properties? These all things are we discussed in the previous session. In this session, we discussed about the second compound of group 15 element, starting from nitrogen. In the last session, we discussed about the dinitrogen, correct? Dinitrogen. What is dinitrogen and what is the property and how it shows different property compared to other elements present in the group 15. It is known as anomalous property or anomalous behavior, and the preparation method of dinitrogen and all that. And also we discussed the second group element. Just we discussed about the ammonia in the last class. Ammonia, correct? Ammonia, NH3. Okay. In the 15th group elements, ammonia is a very important part for your exam point of view. Okay. Ammonia, the preparation of ammonia involves two different methods. One is the laboratory method. So you are already doing the same process in your lab. Okay, lab also. The 0th group elements. 0th group element is ammonia or 0th group compound, 0th group ion. The cation is ammonia. Ammonia is tested by using sodium hydroxide or any base, what we discussed in the previous video. Whenever a base is added to or give the treatment of base to the ammonical salt, ammonium salt. Okay, when ammonium salt is treated with any base, the pungent gas is evolved. That pungent gas is ammonia. Okay, it is evolved in the form of a gas. Okay, and whatever the base is there, that converted into corresponding hydroxides. Okay, this and water also eliminated. Water also formed. That one is the laboratory method using the laboratory reagent. Okay. Next, industrial preparation. Industrial preparation is very important. The industrial means large scale preparation and it involves economical way. Economical way means the commercial. Okay, commercial preparation of ammonia. Ammonia is prepared using raw material nitrogen and hydrogen. These two are available in our atmosphere using pure nitrogen, dinitrogen, and how to get pure dinitrogen. In the dinitrogen topic we discussed the same thing. The pure dinitrogen is prepared using the DAX. Nitrogen, dinitrogen, and hydrogen, that two are compressed under 200 atmosphere pressure and other conditions are required. In the previous video also we discussed what are the things required in preparation of ammonia. This preparation of ammonia is known as, it is industrial scale, therefore it is known as manufacture of ammonia. Manufacture of ammonia. It is explained by, it was explained by Haber's, therefore it is known as Haber's process. Manufacture of ammonia using Haber's process, and the Okay, the preparation involves the combination of nitrogen and hydrogen. Combination of nitrogen and hydrogen is reversible process, hence we require the different condition to get more amount of product. Then what are the conditions required to produce more quantity of ammonia? According to the Leach-Clear principle, under the Haber's process, there are 4 different conditions required to prepare more quantity of ammonia. Then what are the important conditions? These conditions are very important. Suppose we does not use this condition during the Haber's process, the quantity of production decreases. When quantity of production decreases, the industry get lost. Correct? So in the industrial level, we need the economical way. Hence, we require the conditions. So what are the important conditions to require to manufacture of ammonia under Haber's process? First, I write the reaction. What is the reaction taking place? N2 plus H2. Important. Okay. Nitrogen gaseous, hydrogen gaseous state. These two combine under the important condition. And produce ammonia. To balancing this equation, and write 3 hydrogen. Okay. 1 mole of hydrogen, 3 mole of hydrogen gas combine under the condition and produce ammonia. This reaction is delta H is minus 46.9 kilo joule per mole. Okay. In this case, you can write negative also, it is enough. Okay, delta H is negative. What it indicates? Reaction is involve the evolution of energy, heat. Heat evolution means evolution of heat, exothermic. Heat liberated from the system. So this is exothermic process. Okay, it is exothermic process. You should remember the exothermic process for the equilibrium cases. It is equilibrium reaction. Therefore, what type of reaction it is important. Exothermic reaction. Okay. Then what are the conditions required to prepare ammonia? First condition is low temperature. It is also known as moderate temperature. Low temperature around 700 Kelvin. Then question arises. 700 Kelvin, this much of temperature is known as low temperature. Yes, in the industrial scale, 800, more than 800 Kelvin is considered as a high temperature. Therefore, we call it as a low temperature, or better to call it as a moderate temperature. Okay, you should mention it in your exam also. Okay, moderate temperature or low temperature, 700 Kelvin, and the very high pressure is required. These all cases according to the Leach-Clear principle. Okay, high pressure is required. High pressure around 200 atmospheric pressure. It is in terms of Pascal, 200 into 10 raised to plus 5 Pascal. Okay. Next, the catalyst. What are the catalysts required to increase the production of ammonia? Iron oxide. In older days, or before knowing the iron oxide, or iron oxide is a good catalyst. By before the knowing of this concept, molybdenum oxide is used as a catalyst. Okay. Nowadays, iron oxide is used. This iron oxide is catalyst. Iron oxide is used. Next, promoter. Okay. Catalyst is iron oxide. Next, promoter. The role of promoter increase the activity of catalyst. Promoter increase the activity of catalyst. Catalyst when activated, then it increase the production of product. Promoters are, there are two different promoters are used, potassium oxide and alumina, Al2O3. Okay, these are the things required. Whenever we use this much of temperature and pressure, when pressure is increased, high pressure, okay, it is equilibrium reaction, you already know that. It is 1 mole and 3 mole, total 4 moles of reactant and 2 moles of products are there. Whenever pressure, high pressure is applied, what happened in this equilibrium reaction, according to Leach principle, when pressure is applied, to nullify the effect of pressure, the equilibrium shift to right or left side. Here, 4 quantity or 4 moles of reactant are there and 2 moles of products are there. When pressure is applied on the reactant side, the equilibrium shift to lesser number of the molecules. So here 2 molecules, therefore it moves towards the product side. Hence the product increase the quantity of the product. Next, catalyst. What is the role of catalyst? Iron oxide gives the more surface area so that it gives more quantity of product. And what is the need of promoter? It's very important. If you know in depth of the reaction, equilibrium reaction, when very high temperature is applied, it affected on the catalyst. Okay, so it affects on the catalyst. Therefore, to decrease the effect of temperature on catalyst, use the promoter. Promoter activate the iron oxide. Then what is the flow chart? So these are the very important conditions for your exam, as well as the next one is also important. Flow chart of the production of ammonia. Flow chart. Okay. Flow chart means how these reactants are react and use the product. It is explained using one small chart. In first case, the pure nitrogen. Okay, very important. Pure nitrogen. Okay. Next, pure hydrogen is inletted. Aromatics are very important. Okay, this flow chart. Therefore, you should explain with the aromatic. Dinitrogen, pure dinitrogen and hydrogens are passed through compressor. So this is the compressor. What is the role of compressor? What is the role of compressor? Compression. So it is give the pressure. Pressure around 200 atmospheric pressure. What happened? The mixture of nitrogen and hydrogen gas inletted, and after applying pressure come inletted inside the compressor. Compressor with the pressure and it goes to mixed nitrogen and hydrogen goes to catalytic chamber. Okay, next it goes to catalytic chamber. Okay, catalytic chamber is there, and this catalytic chamber is consists iron oxide and promoters. Okay, iron oxides are there. Or better to reverse the process also. This one is inletted in this side and goes to another side. It's also possible. Okay, in one side, iron oxide contains promoters and 700 Kelvin temperature. Okay, contains promoters also. This catalytic chamber, when we increase the temperature, the question arises in exothermic reaction. Suppose we increase the temperature more than 700 Kelvin, then exothermic process is not favored, or this reaction is not favored at higher temperature, correct? Therefore, therefore we need a 700 Kelvin. Suppose we increase the 700 Kelvin, the production decreases and it goes to reactant side. There is a possibility. Suppose we decrease the temperature, catalyst is not activated. Iron oxide is kept activated around 700 Kelvin. Okay, therefore we need 700 Kelvin. Next is passed through. What happened in this case? Nitrogen gas, hydrogen gas, compressor gases goes to catalytic chamber, and here also it was exist in the gaseous state. To liquefy the mixture, condenser is used. After passing the condenser, liquid ammonia is obtained. Liquid ammonia, important. Liquid ammonia is obtained. Liquid ammonia is obtained, and here there is a possibility of missing of 1 or 2 moles of nitrogen and hydrogen molecules. This missed nitrogen and hydrogen gases again pumped and it is recollected and again passed through compressor or directly through catalytic chamber. Here we use the pump to recollect the missing nitrogen and hydrogen gas. Okay, missing nitrogen and hydrogen gases again we pumped. It is a commercial process. Therefore, there is no loss of nitrogen and hydrogen. These are the two raw material easily available. Okay, aromatics are very important here. Okay, because it is a flow chart. Okay, and mentioning about the temperature, pressure, and liquid ammonia is also very important. The flow chart may contain 1 marks in your exam, 1 or 2 marks. Okay, so these are the things that are very important under the manufacture of ammonia under Haber's process. Okay, just I once again recall, nitrogen and hydrogen gas is compressed around 200 atmosphere and again passed through catalytic chamber and gives 700 Kelvin temperature and contains iron oxide. Iron oxide gives more surface area to reacting the nitrogen and hydrogen gas, and mixture and production of ammonia gases take place. That ammonia gas is passed through condenser, then we get the liquid ammonia. And very important thing is the produced products are separated from the reaction condition. What is the need of this extraction or removal of the product? When we continuously remove the products, quantity or molecules of product decreases. Due to that, under 700 atmospheric pressure, the production quantity increases. More quantity of product is produced when we remove the product. It is again according to the Leach-Atweller's principle. Okay, this is the manufacturing method. Next, what are the properties and structure of ammonia? Okay. Properties of ammonia. Properties of ammonia. Structural properties. First is the physical. Ammonia is a gas as well as a liquid. In some cases it is exist in a liquid state, and in some cases it is exist in gas state, depends upon the condition. Ammonia is usually dissolved in the water. It converted into ammonium hydroxide very easiest process it is to carry the ammonia. Carrying the gaseous ammonia is little bit difficult. Therefore, we dissolve in water and get converted into ammonium hydroxide. Carrying of ammonium hydroxide then become easy. It is liquid state. Therefore, we can't say exact state of ammonia. Actually, it is gas. Okay, now room temperature, ammonia is a pungent gas. Pungent gas. Pungent odor. The observation of the zeroth group cation. Correct? That is the odor of ammonia. Ammonia gas is evolved, and it has a freezing point around 198 Kelvin, and it has boiling point. Boiling point is around 239 Kelvin. Okay, around 239 Kelvin. Here we can easily see the liquid state. Okay, after freezing point and before boiling point, it exists in a liquid state. It exists in a liquid state. So, due to the smaller gap between the smaller range of temperature, solvent nature of ammonia decreases. Otherwise, ammonia is the good solvent than water. Okay, water is good solvent because range of liquid state is very high. 0 degree to 100 degree. 100 degree temperature variation is there. But here only around 40 degree variation. So because of that, it is the solvent nature of ammonia is less. Okay. In a few cases we use it as a solvent. Ammonia is a good solvent. Actually, it is a good solvent. But the liquid range, existence of liquid state is very small. Therefore, it is not a good solvent compared to water. Next, structure. Okay, what is the structure of ammonia? You are well known about the structure of ammonia. A nitrogen effects are present at the center and contains one lone pair of electron and 3 bond pair electron, and the structure geometry is trigonal bipyramidal structure and tetrahedral geometry, and shape is trigonal pyramidal. Trigonal pyramidal structure. Trigonal pyramidal. It is the shape, actual shape. When we consider the lone pair of electron, it is a tetrahedral geometry. Okay, geometry is different. Please remember that one. And the bond angle is 107.8 degree. Okay, 107.8 degree. So this is the bond angle. What is the reason of the small bond angle? What is the reason of the compression? Because of the lone pair and bond pair repulsion. According to BSc theory, that part you are already studied in the first year 2 times, I think. You have studied the structure of ammonia. What is the structure of ammonia and what is the bond angle and all that. Okay, so that is the structural property. Next, the chemical properties of ammonia. Chemical properties of ammonia. The chemical properties of ammonia. Ammonia is easily soluble in water, and when ammonia is dissolved in water, it is easily soluble in water. The reason is it acts as a base and gives OH minus. What happened? NH3 is dissolved in water, it gives OH minus, and NH4 plus is formed. It is a reversible. Okay, it's a basic. OH minus is evolved or separated out. So it is a reversible reaction, easily soluble, and extraction also easy. That's why ammonia is carried in the form of liquid state using water. Okay, ammonium hydroxide get converted into ammonium hydroxide. Separation of ammonia from ammonium hydroxide also easy. Okay, because it is reversible process. Okay. Next, other chemical properties are it is easily soluble in water. And the next is the Solution of copper. How to represent the solution of copper? Solution of coppers. When copper is made the solution by treating anything, it exists in a positive oxidation state. That means it is represented +1 or +2 state. Solution of copper is represented in this manner. Copper +2 state. It may be copper chloride or it may be copper sulfate or anything. Okay, copper solution made to react with ammonia. It produces copper and ammonia gives ammonia. Okay, ammonia. Suppose it is sulfate, ammonium sulfate is formed. Okay, it is a complex, blue color complex is formed. Okay, it's important. Okay, it is easily reactive. Ammonia is easily reactive with the solutions of copper and forms a corresponding complexes. Next, other properties. Similar way, AgCl react with ammonia. AgCl react with ammonia forms AgNH3 twice Cl minus. Okay, so 2 molecules of balancing is not required. Okay. You should represent. AgCl, silver chloride react with ammonia and forms a complexes. Again, it forms a white color precipitate soluble. White color precipitate dissolved. So when ammonia is added to white color precipitate, the same process you are already done in your lab, correct? During the test of chloride is made to react with AgNO3 and it forms chloride radical and it forms AgCl, white color curdy precipitate is formed. That white color curdy precipitate is dissolved in ammonium hydroxide, completely soluble. Why it is completely soluble? Because it forms this complex. Please remember the reaction. It is very helpful, and during in your lab you should collect the reaction what happened to you during the salt analysis also. Okay. So these are the very important properties of ammonia. Okay. Next is the oxides of ammonia. That part will be discussed in the next session. Okay. In the next session, oxides of nitrogen. There are 5 oxides. Okay. Because of the multiple oxidation state of nitrogen, it is react with oxygen. Under chemical property, how it react with oxygen. When nitrogen react with oxygen, forms nitrogen dinitrogen oxide, nitrogen monoxide, nitrogen pentoxide, trioxide, pentoxide, and tetroxide. Okay, all oxides are very important for your exam point of view also. Okay, that part will be discussed in the next session. Thank you for watching.